Right, so now that we've built a short catalog of forces, now we want to get into taking a look at physical situations and identifying forces. And then we'll use these eventually to quantify later. So, whenever we identify forces, we have a nice little cheat sheet over here for you about what all the forces are. And then, of course, later we're going to add formulas to that, and we'll try to put together a nice little list of that as well. But the very first thing that we want to do is we want to identify the object of interest. So, whatever it is that we're examining, we want to know what it is. We draw a picture of the situation. So we take a look at it and we see, draw the physical picture of what's going on. And the next kind of 3 and 4 are kind of just thinking about isolating what we're talking about. So drawing a closed curve around the object, because the only thing that we really care about is what is happening to the object. We don't care about everything else that's going on around that. We call that essentially identifying the system, and the system is what we're identifying and isolating to talk about. And then we locate inside of that curved object, we locate every point on the boundary, or if there's other things touching, and we'll talk more about that later to see if there's contact forces. But then we name and label each of the forces acting on the object that are short range or contact forces, and then we name and label all the long range forces acting on the object. So similar to when we set up problems for kinematics, now we got to just be a little bit more specific. There's a little bit more going on when we're identifying forces. So let's go ahead and try an example. So here's our first example, identifying forces on a bungee jumper. So we have a bungee jumper is left off of a bridge and is nearing the bottom of her fall. What forces are being exerted on the bungee jumper? So as best I can, I want to draw a physical situation of the object. I think when you bungee jump that you have a cable that's kind of tied off to your foot that's like stretching out. So all we care about now is we care about what's going on inside of all this right here. We don't really care about the rest of the bungee cord. We don't care about the rest of the world outside of it, but that's it. So we have contact forces that we're identifying. And the contact forces, the person is having a bungee cord, and the bungee cord is stretching, so there is actually a spring force going up, and that is all. And then the only range force is we have the weight going down. So the gravitational force will be going down, the spring force is going up. And as we look at this picture, very similar to what we talked about. The only difference is, and this is sometimes interchangeable, and we'll talk about that as we get through different examples. I identified here, we identified a tension instead. Now, tension is by a rope. I think if it's a bungee jumper, it should actually be like a bungee cord, which stretches, and that's actually more like a rubber band or like a spring force. So in this case right now, we're just identifying forces, so either one is totally fine. One more example problem we have is identifying a skier is being towed up a snow-covered hill. So if anyone's been skiing, there's a lot of times on the bunny hill you get a tow rope. So if I can go ahead and draw the person, take a moment to try to draw the person going on the hill, and pause the video and see if you can identify the forces. So if you were correctly able to identify the forces, you would know that there's a tow rope that's providing a tension going up the hill. And then other than that, there is weight of the person going down the hill. But what you probably forgot, because it's a very, very forgetful thing, is that there's also a normal force of the hill pushing back up on the person. So if we talked about the normal force when we identified our identifying, making a short catalog of forces. The normal force it's called the normal force because it's perpendicular to the surface. So the skier pushes back down on the hill, so the hill pushes back up on the skier. And then the last one, I would call this one kind of more of an optional one, but I think it is a fair one to include, is kinetic friction. So we have friction opposing motion, and because the object is in motion, then we have kinetic friction acting on the object. So this was just a really quick and easy exercise in identifying forces. Where we go from here is now how do we organize these forces so that we can understand the motion of the object, and that'll get into free body diagrams, which we'll talk about in a later segment.